So as we start Unit 7 here, we're going to be looking at trig that's not in a right triangle, so non-right triangle trig. And then we'll also be looking at two-dimensional vectors, okay? And vectors are very much related to trig. We use trig in order to figure out things related to vectors all the time. Okay, but as we're starting here, I wanna go back a little bit and review a couple of things. First of all, in right triangle trig, you are often told to solve a triangle. Okay, can anyone tell us what that means? What does it mean to solve a triangle?
You give out the angles and all the lengths.
Yeah, good. You're going to get all the angles and all the lengths of the sides. Okay, so find all the angles and sides. So you might be given two of the sides and one of the angles, so you're going to have to find the third side and the other two angles. Or you might be given all three sides and none of the angles, and you'll have to figure out what all three of the angles are. Okay? And we're going to learn different strategies for those. Okay? In non-right triangle trig. Okay? And then a couple of things from geometry. The angles of a triangle always add up to 180 degrees. By the way, those of you who don't like radians, okay, we're going to be using a lot of degrees in this unit, so you should be happy. All right, we use some radians, but this kind of branch of trig and getting into vectors often uses degrees a lot more. In a triangle, we're talking about in a triangle, the shortest side will always be across from which angle? The smallest angle, okay? The smallest angle. And the longest side is always across from the largest angle, okay? So automatically I know that if I have, say, sides that are 6, 9, and 10, something like that, okay, I know if this is triangle ABC, which angle is going to be the smallest? C, because it is across from 6, and our biggest angle is going to be A, because it's across from 10. And of course that means B has to be the middle angle, okay? So the other thing here, this is what's known as the triangle inequality theorem, if you remember back from geometry, but the name isn't as important as the concept. The sum of the lengths of any two sides of a triangle has to be larger, greater than the length of the third side, okay?
Else either it wouldn't close or it would be a line.
That's right, okay? If it were shorter, then you could stretch them out as far as they want and it won't make a triangle. It'll just make a line, okay? If it's too far, if it were equal, it'll just lay right on top of it. If it's too short, it'll just never close, okay? So those are some basic facts from geometry about triangles that are going to be really helpful for you to keep in mind as you're doing problems here, okay, in this unit. All right, does that make sense? Okay, now, the question is this. We've had SOHCAHTOA for right triangle trig. How can we relate the sides and angles without a right triangle? Here we have triangle ABC, okay? And you'll notice I drew the altitude there, the height, okay? The way that we're going to be able to relate the sides if we didn't know this height is going to be with what we call the law of sines. And I want to show you where that comes from because it's actually it's a very useful formula, but understanding where it comes from is helpful as well. Okay? You'll notice here, like I said, I drew h as the altitude or the height of this triangle. Okay? And since ABC was not a right triangle to begin with, I drew this height so that I would have a right triangle on the left, and I actually have a right triangle on the right side, okay? So here I have this right triangle over here, and I have this right triangle here on the right as well, okay? Now, looking at the left-hand side, notice B on the bottom has been split up into like pieces. So I can't really use this side B. Okay? I can't really use that because I don't know how much of it's over here and how much of it's over here. Alright? But as I look at this triangle here, what trig equation could I write?
Sine A over sine of A.
Well, no, just using the right triangle right here.
Sine of A equals H over C.
Okay, good. Sine equals opposite over hypotenuse, okay? Here's our angle A. The opposite side in the right triangle is that altitude that we just drew, H, and the hypotenuse would be this side C. So sine of A equals H over C. Okay?
We do the same thing with angle C.
We can do the same thing with angle C, alright? So what equation would I write there?
Sine of C equals H over A.
Okay. Sine of C equals H over A. Now, question here. Does anyone see how we could put these together? Where's the connection?
Both have an
The H. They both have an H. So what do you suppose we could do?
figure out H.
If we divide them, we could cancel it out or something.
Okay, somehow putting these things together so the H's are gone. What, Davi, what'd you say?
We can try to figure out the H if we have some more information.
Okay.
Sine A times C equals sine C times
Wait, what did you say, Han?
A. Sine A times C equals sine C times A.
Huh. So you're saying sine of A times C will equal the sine of C times A. How'd she get that?
Oh, then they both equal H.
They both equal H. Yes, if I took this equation here and I multiplied by A over it on both sides, H would equal A sine of C. And over here, if I multiplied both sides of this equation by C, H would equal C times the sine of A. So since they're both equal to H, I can make them equal to each other. Okay? Now, here's where we get the law of sines, okay? What I'm going to do here is I'm actually going to divide both sides. Okay, change colors. I'm going to divide by the C and by the A. Okay? Because I want to get the A over on the side that has angle A, and I want to get the C over on the side that has the angle C. So you'll notice the A will cancel out the A over here, leaving me with sine of C over C. Okay? Over here, the C's will cancel out, and I have sine of angle A over A. Okay? Now, if I had wanted, I could have divided by the sines of the angles instead of the sides themselves. Okay? If I had had C sine of A equals A sine of C, I could have divided by sine of A times sine of C, And notice here the signs would cancel out there, leaving me with c over sine of c. And over here we would have a over sine of a. Okay? So you see here, it doesn't matter which one you put on top. Okay? In fact, they're the two versions of the law of sines, which is what we're deriving here, are one has all the angles on top, one has all of the sides on top. And the basic rule is this: just put whatever you're trying to find on top, and that'll make your algebra easier. Okay? So, now I will extend this a little bit, because notice we haven't done anything with B and B. But we could go through a similar process, and we could actually prove that side B and angle B have a similar relationship here. So here we see that side A over the sine of angle A equals side B over the sine of angle B equals sine C over the sine of angle C. Okay? Or down here you have this reciprocal form with all the angles on top and all the sides on the bottom. Okay? So basically, we're going to use this if we're trying to find a side, because the sides are on top, so it's easier algebra. We're going to use this if we're finding an angle. Okay? So one question that's kind of natural to ask is, okay, so when would I be able to use this method? Okay? The question, and the reason why we're saying this is because you actually cannot always solve a triangle using the law of sines. Okay? For example, if I knew the three sides of a triangle, we'll use A, B, and C again, were, we had it before, it was, what, 7, 9, and 10, or something like that? Okay? If I tried to find angle A, okay, I'd have the sine of angle A over 10 equals sine of angle B over 9. You say, well, whoops, I've got two different variables there. Okay, I don't know either of those two angles. Okay, so, okay, well, what if we tried to use angle C instead? All right, well, sine of angle C over 7. Oops, I don't know either of those two angles again. So I'm missing something here. Okay? So the law of sines will not work for every triangle that we're trying to solve. It all depends on what we know about the triangle to start with. Obviously right here, if I know all three sides but don't know any of the angles, I'm stuck. I can't use the law of sines. So one of the cases where we can use the law of sines is if we're given two angles and one side. Okay? If we're given two angles and one side, so here I'm told that angle A is 93 degrees, angle B is 28 degrees, and side A is 23 meters. Okay? Question?
What if you have two sides and one angle?
We'll get to that. Sometimes it'll work. Okay? So let's say, what could I actually solve for in this case?
B,
Angle C.
side B.
Okay, start with the simple stuff, right? We could figure out angle C really easily, right? How do we find angle C?
180 minus 93 minus 20.
There we go. Okay, subtract everything from 180. Don't forget that easy stuff, all right? And I think we get 59, isn't that right? 59 degrees? It's 11, 20, 40, 90, 90. Yeah. Okay? So we got 59 degrees. Then what was what were some of you guys saying other than angle C?
Side B.
Side B, okay? So if I wanted to find side B, it would be B over the sine of angle B. So I'm putting 28 degrees in there, sine of 28 degrees. Okay? That's going to equal,
23 over sine of 93.
very good, 23 over the sine of 93 degrees. Okay? So you see how we're using our law of sines. The angle and the side across from it are paired up here in a ratio. Okay? So, this is why we put the side on top, because the algebra is pretty easy. All I have to do here is multiply by the sine of 28 degrees on both sides. That cancels, and I have B equal to whatever that is, okay? So 23 times the sine of 28 divided by 93. Okay, so we get 10.81. As a general rule here, guys, when you're finding sides, give me 2 decimal places. Okay? And this is in meters. Okay? We're going to be doing a lot of word problems with these, so make sure that you give units with your answer as well. Okay? So this would be 10.81 meters for side B. Now, one thing that will help you get into the habit of doing it now, okay, so that later when it's really necessary, you can do this. As you solve for things, write them in the triangle, okay, so you can see the relationships of where everything is. You're not just looking at angle B and side B, you actually see it in the triangle there, okay? Because now that we have this, and we also figured out angle C was 59 degrees, we can do the law of sines again to figure out side C, okay? Now here's a question. What might you be tempted to use that you're not allowed to here?
Sine of 59 equals C over B.
Hang on. The Pythagorean theorem.
Oh, C over
Okay? This is not a right triangle, so you cannot use the Pythagorean theorem. That's a very common mistake that students will make. And they say, oh, well, A is going to be the longest side because angle A was the biggest angle, so that must be our hypotenuse. And then they try to do the Pythagorean theorem. It doesn't work because it's not a right triangle.
It's almost.
So, what Davy was saying, we're using
No, I said a mistake could also be the person trying to use sine of 59 equals C over 23.
oh yeah, if you
As if
don't
it
pair
was a
them up
right
correctly. Oh yeah. Oh, I get what you're saying. Use it like trying to make it opposite over hypotenuse or something. Yeah. You cannot use any right triangle stuff when you don't have a right triangle. And I know that's kind of obvious when you say it, but it's very easy to accidentally do. Okay? So here we would have to use the law of sines again. C over the sine of 59. Good. Equals 23 over the sine of 93. Okay? Or we could have used the 10.81 over sine of 28. Since I rounded that, I'd rather use what I'm given if I can, all right, to make it more precise, but either one would work. And we should get C equal to 19.74. Okay? Meters. And now we have solved the triangle. We know all 3 of the angles, and we know all 3 of the sides, so we're done. Okay? So now we know that if we are given 2 angles and a side, we can automatically use the law of sines to solve it. Okay? And the nice thing about that is it's not only 2 angles and then a side across from one of those angles. Notice here, we know the side that's between the two angles. Okay? And in this case, we actually would have to find angle C first. Okay? So you add these up, you get 121, subtract from 180, we get 59 degrees again. And now I can solve for one of my other two sides. Okay? So what do you see as kind of essential here as far as the angles and the sides that we know?
You know all the angles.
You need at least one of each.
We need at least one of each.
You need,
Two angles.
you need two.
Two of each.
you
Okay?
need two of one of them and then
Two of one, yeah.
Two of one and one of the other. Okay? Sometimes if we know two sides and an angle, as we'll see later, it doesn't always, we can't always do it that way. But in other cases we can. And then in other cases we get it, but there's actually two possible answers that we have to figure out between. The key here though is this, okay? The key is you have to have a pair that's across from each other. And that is so that when you put it in the law of sines, one of those ratios is complete. We know exactly what it equals. If we didn't figure out that sine of that was 59 degrees, then each of the ratios in the law of sines would have a variable in it, and we'd never be able to set up an equation we could solve. Now, however, we have 9 over the sine of 59. We have this completed ratio, and we can use that to find A, or we could use that to find B. Okay, so we could use this equation to find B, we could use this equation to find A. Okay, some people like to even set it up this way,
I like
just to save some writing. Okay? If that confuses you, just write it as two separate equations. Okay? Does that make sense? It's really not too bad of an equation to use once you get the hang of it. Okay? Alright, so what I want you to do, try to finish this one off. Go ahead and find what A and B actually are. Okay, we've got it set up, so just practice solving it here on your own. Again, make sure your calculator's in degrees, and make sure you're using your TI calculator that you'll be using on the test. Okay, some of you are still really, for lack of a better word, lousy at using your calculator, okay? You're struggling to use it and you're wasting time and making mistakes because you just don't know how to use your tools properly, okay? So practice, okay? So give that a shot here and we'll see what you get. Alright, so here we are working on solving these things, and if you do some of the algebra, we see that B is 9 over sine of 59 times the sine of 28, and Yudi, I know you got this one. What'd you get for B? 4.93?
Yeah.
Alright, good. Okay, so 4.93 meters. Okay. And for A, we had 9 over the sine of 59 times the sine of 93. Does someone want to tell us what they got for that? Rachel? 10.49. 10.49. Okay. Does that match what you guys got? Okay. Now, one way just to make sure and double check yourself, remember I said as you find stuff, write it in. 4.93 meters, 10.49 meters, okay? If A is our biggest angle, then side A ought to be the longest side, and notice it is, okay? B is our smallest angle, so across from that, 4.93 is smaller than the other two sides. So I know it is. Also, this is almost 5. 5 and 9 is 14. That's plenty bigger than 10.49. So I know it works with that as well. Those are some little things that you could do to really quickly double check and catch little errors that you might make.
Susan, I love how side B on the graphical side is so much larger than side C.
Yeah, diagrams are not necessarily drawn to scale, okay? So don't go by what they look like.
The angles 59 and 28 should be.
Yeah, probably should have drawn it with B and C switched, but that's the thing with these though too, guys. Don't just look at it and say, well, that kind of looks like it should be whatever. Go by what the numbers say, okay? All right. So, you got a little practice. I gave you a number of practice problems here in the back. The required IP isn't all of those, but can give those a shot and do a little bit of practice with the law of sines.